Hello all, welcome back. So in this today's session we will see what is the T or toggle flip-flop, right? We will implement by using of the NAND gate representation, right? So in previous class we have explained the operation of the JK flip-flop, right? So JK flip-flop, so if you do some modification then it will become the T flip-flop operation, right? So if you remember what is the logic circuit diagram for the JK flip-flop, it is something like this, right? Right, let me try quickly. So just first we are taking the latch, right? So the output will be connected to the input. Then we are going to implement the clock pulse operation, right? So how many inputs we have? 3, right? So one is called as the clock signal, another one is a J, another one is the another one is the K. So this third terminal will be connected to the output of what? Qn. This will be connected to the output of the what? Qn bar, right? So this is what we have explained in the previous class. Now how to make this JK flip-flop in terms of the T flip-flop or toggle flip-flop means just you short the J value, K value, so that instead of 2 terminals it will become the single value, nothing but the T flip-flop. If you observe here, this is JK flip-flop, but somehow we are making the short of the J value, K value, so that we will be getting the single input terminal value, right? So T means we should require only single input terminal value, right? By shorting the J value, K value will be getting the T value, right? So the remaining part will be same. So here we will be having the Qn, one more is the Qn bar. So see that how many inputs we have? One input along with the clock pulse, outputs are Qn, one more is the Qn bar, right? So before going to learn the truth table operation and characteristic equation, first we have discussed the toggle, right? So what is the meaning of toggle operation? Toggle operation means changing the binary number either from 0 to 1 or 1 to 0 is called as the toggle condition, right? So one more point to remember is that, so when T means we are implementing the T flip-flop, right? So T means single input, right? How many possibilities we will be getting? 0 or 1. It means that if you observe here clearly, T equal to 0 means what? T is not activated, right? 0 means what? T is not activated, right? So what is the meaning of 1? T is activated, right? So try to understand. T equal 0 means T is not activated, T 1 means T is activated. So what is the meaning of T? Toggle. If T is activated, then what will be happen? If you are giving the 0, what is the output? You will be getting 1. If you are giving 1, what is the output? You will be getting 0. This is what we called as the toggle operation. When this toggle operation will occur? When T equal to 1. If you have this still doubt, what we will do is, we will consider inside of the circuit, then we will try to find the output value, right? So let me take T equal to 1. It means that what is the value here? 1. So the same value will be passed to here, right? The same one will be passed to here, right? Now what is this value? This value also 1. Remember that always clock pulse value should be 1, right? Now this value is required, right? This third input terminal required is, right? So first when T equal to 1, we will take that assumption either 0 or 1. Suppose if you take assumption equal to 0, you can take anything, right? Either 0 or 1. So if I take 0, what should be this value? 1. Now what this value is connected to this one, right? This value is connected to here, right? So what is that value? 0. Now this 1 is, right? Qn is here, right? So this will be connected to where? Here. Now what is the meaning? 1, 1, 1. According to the NAND gate, what is the logic gate 1 output? 0. For logic gate 2, 1, 1, 0 means what is the output? 1. Now see that logic gate 3, logic gate 4. Second terminal is unknown, second terminal is unknown. For which one we can directly find the output? If you listen my previous classes, then this is nothing, guys. If you don't understand still, go to the basic SR flip-flop operation or RS latch operation, then you will be understanding this one, right? So for which logic gate we can find the output directly? We can find the output for the logic gate 3. So what is the output? The output is the 1. Now for this one, what is mandatory? If any one of the input equal to 1, second input terminal is the mandatory. How to get this value? See, this value is this one, right? So what is the current output? We have 1, right? This will come to here, right? So 1, 1 means what is the answer for logic gate 4? 0. Now see that what is the value we have given? T is activated, right? I told T is activated means excuse me, T is activated means toggle is activated. Toggle means changing the value from 0 to 1 or 1 to 0. See, if you are giving 0, what is the value you are getting? 1. Here it is 1. So this is what we called as the toggle condition. See, when T equal to 1, If assumption equal to 0, it is getting the 1. If assumption equal to 1, it is getting the 0. It means that when t equal to 1, it will perform the toggle operation. Right. Now if you have still the doubt, you just perform the t equal to 0, then find out the what is the answer. I'll give you just pause the video, then try to find the output. When t equal to 0, you make assumption qn equal to 0, then try to find the output value. What is the answer we are getting? No change, right? So we still don't understand. Now we'll consider the t equal to 0. What is the assumption value you can consider? 0. What is this value will be? Complement means 1. Where this value will go? Here, right? Sorry, this value will go to here, right? So t equal to 1. Always clock equal to 1. Now what is this value? Here also we will be having the value is what? 0, right? Now what is this value? This third input terminal which is connected to here, right? This value will be 0. Then clock value equal to 1. This value equal to 1. See that if any one of the input equal to 0, output equal to 1. But what is the requirement here? Second terminal is mandatory, right? If any one of the input equal to 1, then how to get this value? From here we can get this value, right? So what is this value? 1, right? So what is this value? 0, right? This value, right? So 0, this value, right? So 1 1 means what is the output value? 0. So 0 1 means what is the output value? For logic gate 4, the output value equal to 1. So see that if assumption value equal to next level value, then this is called as the no change condition. See, if toggle is not activated, then what we will be getting? The assumption value equal to the next state value. Simple thing, guys. When t equal to 0, no change operation. When t equal to 1, just you will be finding the toggle output. Toggle output means 0 to 1, 1 to 0. When t equal to 0, toggle is not activated. 0 means 0, 1 means 1. So if you observe here, the same thing you will be finding here. Right. Now finally we can find the characteristic equation for the t flip-flop. Right. So what is the characteristic equation for the t flip-flop? First, how many outputs we have? Single output, right? What is that value? Qn plus 1. Just try to find out the minterms value. Right. So this is 0, 1, 2, 3. What is the minterms we are getting? SOP function, right? So 1, comma 2, right? So 2 input means which variable k-map is required? 2 variable k-map is required. Just I am taking the 2 variable. One input is t, another one input is qn bar. It is something like this, t qn. So what is the minterms we are getting? 0 1 2 3, right? Cell variable. So 1 2. This is means 1 2, right? Only single grouping. What is the answer? Qn plus 1 equal to t bar qn. For this one, what is the answer? T into qn bar. This is the characteristic equation for the t flip-flop, right? Simple thing. When t equal to 1, toggle. When t equal to 0, no change operation. That's it.